Alright.
Okay, let's have it.
Area of a circle.
Pi square.
Area of a circle.
Pi square.
Circumference of a circle.
2 pi pi d.
I can't hear you.
2 pi pi d.
When you travel across a parallel line.
Alternate angles are equal. Corresponding angles are equal. Vertical opposite angles are
The
equal.
sum of angle on a straight line.
180 degree.
I can't hear you.
180
The
degree.
sum of angle in a triangle.
180 degree.
I can't hear you.
180 degree.
I can't hear you.
180
The
degree.
sum of angle missing at the point.
360 degree.
I can't hear you.
360
The
degree.
sum of angle in a quadrilateral.
360 degree.
I can't hear you.
360 degree.
I can't hear you.
360
A
degree.
plane shape with 3 sides.
Triangle.
I can't hear you.
Triangle.
I can't hear you.
Triangle.
4.
Quadrilateral.
I can't hear you.
Quadrilateral.
5.
Pentagon.
I can't hear you.
Pentagon.
I can't hear you.
Pentagon.
I can't hear you.
Pentagon.
6.
Hexagon.
I can't hear you.
Hexagon.
7.
Heptagon.
I can't hear you.
Heptagon.
8.
Octagon.
8.
Octagon.
9.
Nonagon.
9.
Nonagon.
10.
Decagon.
Sum of interior angle of a polygon.
2n minus 4 bracket 90.
I can't hear you.
2n minus 4 bracket 90.
Sum of exterior angle of a polygon.
360 degree.
I can't hear you.
360 degree.
I can't hear you.
360 degree.
Minus times minus.
Plus.
Minus times minus.
Plus.
Plus times minus.
Minus.
Plus times minus.
Minus.
Plus times minus. Minus times plus.
Minus.
Minus times plus.
Blasting from Ekota of Ekota tutorial. Of course, all my guests who are there, of course, this topic is going to be useful for every one of us. Be it primary, secondary, SS, 189, you need to know how to divide. Now, rules of divisibility. 2. If the last digit is even or 0. If the last digit is even or 0. 3. If the sum of the digit is divisible by 3. If the sum of the digit is divisible by 3. 4. If the last 2 digits form a number divisible by 4. If the last 2 digits form a number divisible by 4. 5. If the last digit is what? 5 or 0. I come again. If the last digit is 5 or 0. 6. If the last digit is even and the sum of the digit is divisible by 3. 7. 7 is a prime number. 17 is a prime. 47 is a prime number. 8. If the last 3 digits form a number divisible by 8. And 9. If the sum of the digit is divisible by 9. 10. If the last digit is 0. We are going to look at numbers, different number, how to know that is it divisible by 2 or is divisible by 3. Most of the time, if you have a question that is in form of fraction, which you know how to divide. This rule is a basic thing that you need to know if at all you want to excel mathematically. Now, sit down, take out your book, and let us go on how to divide numbers. We want to check now. Check if divisible by 2, 3, 4, 5, 7, 8, 9, 10. If this number is divisible by 2. Let's check. Rule for 2. If the last digit is even or 0. The last digit is 0. I'll say number 1. Divisible by 2. Because the last digit is 0. You need to know the rule for 2 if the last digit is even or 0. What about for 3? 3. If the sum of the digit is divisible by 3. Without any remainder. Let's see. For 3. Let's say we say 3 plus 2 plus 5 plus 5 plus 0. 3 plus 2. 5. 5 plus 5. 10. 10 plus 5. 15. 15. So 15 divided by 3 give us 5. Also what? Divisible. Clear. Now, the last one, number 4, is to check if it is divisible by 4. Rule for 4, if the last 2 digits form a number divisible by 4. The last two digits here, last 2 digits equals to what? 50. This is the last 2 digits, 50 divided by 4. 2 here, 25. 2 here, you have 2. 2 here, what do you have? 12 over number 1 over 2. So there is not what? Not divisible. Now, rule for 5. For 5, if the last digit is 5 or 0, you don't need to waste your time. Last digit is what? 5. So what do you say? Divisible by 5. Number 6. For 6, let's check if it is divisible by 6. What's the rule for 6? If the last digit is even, is this one even? No. not even. You say, not divisible. From the first statement has contradicted the whole thing. It has contradicted the rule or the system. Rule for 6. If the last digit is even and the sum of the digit is divisible by 3, of course, 0 is end with 0, 1, and the sum of the digit is divisible by 3. Now let's see. 3 plus 2 plus 5 plus 5 plus 0. 3 plus 2, 5. 5 plus 10, what do you have? 15. Divisible by what? 3. What do you see? 5. You can say what? Divisible. Now, rule for 7. 7 is a prime. 7 is a prime. 17 is a prime. 37 is a prime. 47 is a prime number. A solid number. 7 days make 1 week. Now, let's see rule for what? 8. Let's go for 8. There is, when it comes to 7, except because 7 is a prime number, so it does not have any specific rules. So you must note that. Now, when it comes to what? 8. If there was a rule for 8, now, what's the rule for 8? If the sum of the digit is divisible by 8. If the sum of the digit is divisible by 8. Now, let's see. We have 3 plus 2 plus 5 plus 5 plus 0. Everything here, it gave me 50. Okay, let's see. 5 plus 5, 10 plus another 5, 15. What do you have? 15 divided by 8. You say not divisible, because of course there will be remainder. Rule for 9. If the sum of the digit is divisible by 9. If I add everything, 3 plus 2 plus 5 plus 5 plus 0 divided by 9, 15 divided by 9, you say give me the remainder, you say what? Not divisible by 9. Now, what about 10? If the last digit is 0, you can see the last digit here is 0. So, do for 10, you say divisible by 10. If you're hearing me, I'm properly in like in blessing from headquarters of Mecca tutorial. Now, move to another topic then, factor and multiple. What is factor? Factor is any number that divides a number without any remainder. Factor, like the factor, let's say, for example, I have 10. What are the factor of 10? 1 can go in 10, 2 can go in 10 without any remainder. 5 can also go, and 10 can also go without any remainder. Now, let's see. Let's find the factor. Remember, my reference note is New General Mathematics 2. Let's see, we have a question here. Say, find the factor of the following. A to be what? 12. Now, if I want to find the factor of this, there are many schools of thought. Now, you can adopt this. You can take this to be what? 12. You rule. What are those things that can go in 12? 2 here, what do you have? 6. 2 here, you have 3. 3, you have 1. Take it. The first factor here is 2 against this. 2 and 6. You add the first one, 2 and 6. 2 times 6, 12. The next one you say 2 times 2, 4. 4 against 3. We have 4 by 3 is a factor. Then the next one, 2 times 2, 4. 4 times 3, you have 12. You have 12 against 1. So you can write this one, you can answer the factor of 12. We write it in ascending order. Yeah, let's go. 1, 2, 3, 4, 6, and 12. These are the factors. We can also see have another one. Let's see. Another one, if you have, let's see, 18. 18, I'll take 18 and I see what are those things that can divide. Start with the lowest number. 2 here, you have what? 9. 3 here, 3. 3 here, 1. The first factor here is what? 2 times 18. 2 against 18. The next one is 2 times 3 is 2 times 9. The first one here will give us 18. Second one is going to be 2 times 3 is 6. 6 against 3. That is 6 times 3. Will still give us 18. The next one is 2 times 3 is 6. 6 times 3, 18. You have 18 by 1. So if I want to write my factor, the factors of 18 are going to be in ascending order. 1, 2, 3, 6, and 18. I've gotten my 9 and 18. Clear. 9 and 18. You can also see, let's see another one. If you have 20, factor of 20. Number C, factors of 20. Your rule C, 20. I divide. Let's see what are those things that can go. 2 here, what do you have? 10. 2 here, we have 5. We also have 5 here, we have 1. What do you have in a crossing manner? This one you have 2 by 10. 2 times 2, 4. 4 against 5. 4 by 5. And the last one, 2 times 2, 4. 4 times 5, 20 by 1. So you write the factors out. Factors of 20 becomes what? 1. We have 2. Which other one do you have again? We have 4. And we also have what? We have 5 and 5. 10. 10 is here, and we also have 20. These are the factors of yeah. Now still another factor. Now prime numbers, because we must still get to prime factor. But this one prime number. What are prime numbers? These are numbers that can only be divided by what? 1 and it's what? Self alone. 2, 3, 5, 7, 11, 13, 17, like 19, like that 23. All these are what? Prime number. But note, I want you to know something here, that please, that 1 is not a prime number. 1 is not a prime number. As I said, prime numbers we have 2, 3, 5, 7, 11, 13. 13, 17, 19, 23, and so on, 29, 31. Like this, you have 47, 37, like that. All these one are prime numbers. So he said prime numbers are those numbers that can only be divided by what? 1 and a set only. Note that 1 is not what? A prime number. Are we clear with that now? Now, let us see, from prime number we move to what? Prime factors. Prime factors, what do you understand by prime factors? Prime, you all know that prime, a number that cannot divide, that can only be divided by 1 and itself. Then prime factor, that is in any given number. The first thing you need to do by finding the factors, then the next thing is going to be what are the prime numbers we see and the factors. Let's see, if you have like a 10 prime factors, you have in 10. First and foremost, find the factors. Factor of 10, I got the factor of 10. See, I say 2 here, what do you have? 5. 5 here, what do you have? 1. Now, the prime factor here, if I say the factor of 10, and what? You have what? 2 and 5. That is 1, 2, 5, and 10 itself. Then the prime factors, what are the prime factor here? Remember, 1 is not a prime. You have 2 and you have 5. You are done with that. The prime factor of 10. Now, still express the following as a product of prime factor. As a product of prime factor. That is, everything we are going to use here is going to be what? A prime number that we use. Now, watch, for the same question as a product of prime factor, I'll take this one, my 12. I wrote watch. 2 here, what do you have? 6. 2, all this major is prime number you use. 2 here, what do you have? 3. I see you 3 here, what do I have here? I have it to be what? 1. So, what do we have here? We have, what are the factors? We have 2 times 2 times 3. 2 times 2 times 3. Expresses as the product of prime factor. So another one is a number, okay, the big question which is 18. Please note new general mathematics book 1. Now another one is 18. Let's see 18. Make sure it is prime numbers that you use. Let's see, 2 here, what do you have? 9. 3 can go here. 3 here, what do you have? 3. 3 here, you have 1. To represent that, this one become what? 2 times 3 times 3. You remember, let me not tell you, if you are to do this in index form, this become 2 raised to power in exponential form, 2 raised to power 2 times 3 raised to power 1 in index form. Like this one too in index form, you have to represent in index form. Remember, if you find the factor in index form, this one become what? 2 raised to power 1 times 3 raised to power 2. Let's see another one. See, the 3 question 28. 28 I rule. 2 here, what do you have? 14. I can use 2 again. 2 here, what do you have? 7. 7 here, you have 1. So as a product of prime, I will write 2 times 2 times 7. But in index form, to represent this one in index form, this one becomes 2. 2 making a 2 day here. 2 carry raised to power 2. How many 7 here? You have 7 raised to power 1. Now, the last question here is 30. The last question here is 30, which I think you can try at home. Now, let's see. This one you have 2, what do you have? 15. 3, what do you have? 5. 5, you have 1. So, as a product of prime factor, what do you have? That's going to be what? 2 times 3 times 5. In index form, 2 raised to power 1 times 3 raised to power 1 times 5 raised to power 1. Are we clear with that now? Okay, that is for that. Now, LCM and ACL. LCM, lowest common multiple, and ACL, highest common factor. But this time around, let us see here. Before start, let's start with ACL. Let's understand what is ACL, how they work at ACL. We have different school of thought and we have different methodology when it comes to this. Now, please see what the way I'm going to do it here. HCF of this. For find the factors of this. Now, we have 63. I'll take the first 63. I roll. What are those things that can go here? 3 can go here. 3 here. 3 in 6 you have 2. 3 here 1. 3 can still go. 3 here you have 7. 7 you have 1. I keep it. I go to the second one, which is 42. I wrote 42. I see what can go here. 2. 2 here. 2, 1. 3 here. You have 7. 7. You have 1. Other one, I go with 21. I rule 21. 3 can go here. You have 7. 7 here. You have 1. Now, I will write all this thing out. Watch. 63. Now 63 you have 3 times 3 times 7. For that of 42, you have what? 2 times 3 times 7. The third one, you have 21. What do you have? 3 times 7. Now I'll check here. What are those things that complete? That appear here, appears here, appears here. Now let's see. What the first one? Let's see. 3 appears here. Okay. 7 appear here. AG. That is to say, my HCF become what? 3 times 7. That is going to be what? 21. That's going to be what? 21. Okay. Yeah. Find the HCF of 144, 216, and 360. Remember, take them one, separate them. 144. Let's have it here. 2 here. 2 in this you have 7. This one you have what? 2. What again? 2 here. What do you have? 36. Let's see go here. 2 here. What do you have? 18. 2 here. What do you have? 9. 3 here we have 3. 3 here you have 1. I keep it. I go to the second one. 216. I rule. Rule of divisibility 2. If the last digit is even or 0. This one is even. Definitely 2 can go here. 2. 2 in 21, you have 10. And 2 in 16, you have what? 8. 2 here, what do you have? 5 and what? 4. Let's see, go again. It's end with even. 2 here, what do you have? 27. 3 in 27, we have what? 9. 3, what do you have? 3. And 3 here, you have 1. Next one, I move again. I move to 360. 360. What can I go? Let's start with 2. 2 here, what do you have? 180. 2 here, you have 90. 2 here, you have what? 45. Rule of disability. 2, if the last digit is even or 0. 3, if the sum of the digits is divisible by 3. That is 4. If the last two digits form a number divisible by 4. And 5, if the last digit is 5 or 0. This one, 5 can go here. 5 here, what do you have? 9. Let's see, go again. 3. 3 here, what do you have? 3. And 3 here, what do you have? 1. You write all this on and see what is common in between. 144. You have 2 times 2 times 2 times 2 times 3 times 3 as a product of prime. Express it first. Then 216. We have what? 2 times 2 times 2 times 3 times 3 times 3. Then for 360, what do you have? 2 times 2 times 2 times we have 5 times 3 times 3. Let's see those things that are common. Let's start. The first one, 2. I write it. This one to come up times 2. Yes, come on, times 2. What is common again? 3, 3, 3, 3, 3. Watch out this. This 3 is common here. What do you have here? Times 3. Times 3. Another 3, 2 is also common here. Look at this here. Another 3 is also common here. I use what? Times another 3. So you can see this one. They are remnant, so leave this one, those ones that way because they are not what's common. So my HCF is going to be what? Let's have it. 3 times 3, 9. 9 times 2, 18. 18 times 2, 36. 36 times 2, what do you have? 72. So my answer, the HCF is 72. Please, if you are anywhere you are watching, I am Corporal Bola Abdulakim, classic from headquarters of Mecca Tutorial. For more of it, for any online program, you can as well see meet us on 08039096141. Thank you. Yeah. Now this time around, it is LCM, lowest common multiple. Say the way I am going to do. Remember, during the ACF, I try to separate them. This time around, I'm going to join them together and watch. LCM A, 4 and 6. I'll write 4, I roll. I have my 6, I roll. What are those things that can go? Let's go. 2 here, 2, 2 here, 3. Yeah, 2 again, you have 1, 2 cannot go here, I bring it down. 3 here, 1, and this one become 1. My LCM is going to be what? 2 times 2 times 3. 2 times 2, 4, 4 times 3, what do you have? 12. Now, my B, the LCM on 9, 12. If you like, let it be 5, 6, 7. No issue. No issue. Now, small thing like Boko Haram, a small thing to die now. Let's go. We have what? 9. We have 9. We have 12. We have 15. If it ever tested, you tested. They are tested and they are tested. And so, make nothing, no good thing for now. Let's look at this now. We have, what can we go here? Let's say 3. 3 here, what do you have? 3. 3 here, what do you have? 4. 3 here, what do you have? 5. Let's use the 3 again. 3 here, what do you have? 1. 3 cannot go here, you leave here 4. You still bring this one 5. What can go again? Let's say 2. 2 here, 1. This one still become 2. Bring out the 5. 2. What do you have here? 1, 1. Still bring out the 5. And here you have 5. 1, 1, and 1. So my LCM here is going to be what? 3 times 3 times 2 times 2 times 5. Now 3 times 3 is 9. 9 times 2, 18. 18 times 2, 36. So we have 36 times 5. 5 times 6, 33. 5 times 3, 15. 100 and what? 80. It becomes 180. And the last question here. The last question here is going to be. Now, next one, let's see. 9, 10, 12, 15. No shaking. Check is no day. I'll play my password. Alright, let's see now. Let's have it. This one. Let's go. 3 here. What do you have here? 3. This one still remain 10. 3 in 12. You can go. You have 4. 3 here. You have 5. 3 here. What do you have? We have 1 here. 10. 4. 3 cannot go here. 5. Let's see again. What can go? What about 2? 2 here. You have 1. You have 5. 2. So you have 5. 2. Let's see. 1, 5, 1, 5, 5, 1, 1, 1, and 1. Good. Now my LCM is going to be 3 times 3 times 2 times 2 times 5. 3 times 3 is 9. 9 times 2 18. 18 times 2. 18 times 2 you have 36, and again 36 times 5 again. 5 times 6 30. 0 carry 3. 5 times 3 is 15 plus 3. What do you have? 180 again. Is that clear now? Sit up, citizen. Thank you very much. That is one on LCM. Yes. Let's move around. We're still moving to indices and standard form. Indices and standard form. You see, when we talk of indices, we are talking of those mathematical representation in an exponential form. In exponential form, that you say, in other words, you say raised to power. It could be number. Maybe you have x raised to power 10, 10 raised to power 4. Anything so far in raised to power, you call it in indices, or you say it's exponential form. In solving this, I say when you go to Ilu Afoju, you have to behave like Afoju. Now, when it comes to indices, we have laws governing it that you must obey if at all you want to do anything. Now, the first law says x raised to power a times x raised to power b equals to x raised to power a plus b. X raised to power a divided by x raised to power b equals to x raised to power a minus b. X raised to power 0, that is anything raised to power 0 equals to what? 1. X raised to power a bracket b equals to what? X raised to power a times b. And you still have further, you have x raised to power a over n to be what? N root x raised to power a. Like that. Let's quickly see the application of all these laws. Now, if I have what? Example 1. X raised to power 5 multiplied by x raised to power 3. The two of them, this one become x raised to power 5 times become plus 3. It become what? X raised to power 8. If I have y raised to power 5 times y raised to power 4 times y raised to power 3. Y, and 3 of them are in exponential form, that is indices form. I'll take it to be what? Y raised to power 5 plus 4 plus 3. That becomes y raised to power what? 12. It can come this way. What about if you have y, you have 2, let me just say 3y raised to power 4 times 2y raised to power 3. Everybody, number for numbers, letter for letter, sign for sign, indices for indices. You take this, join this one together, 3 times 2. What do you have? 6. Y in exponential form, you use law of indices. That is y raised to power 4 plus 3. This becomes 6y raised to power 7. Remember, my reference note is for New General Mathematics book 2. Let me see another one again. We have m raised to power 5 times m raised to power 3. They become what? M raised to power 5 plus 3. What if it comes in terms of number? 10 raised to power 5 times 10 raised to power 4. 10 represents this one become 10 raised to power what? 5 plus 4. This becomes what? 10 raised to power 9. What if you add something like this? You have what if you come this way? X raised to power 7 times x. Note this the same thing as x raised to power what? 1. Note this question. Don't go on error. To buy error, so you need to know, follow no rule. This will become x raised to power 1. So this become x raised to power what? 7 plus 1. This become what? X raised to power 8. X raised to power 8. For example, now what if you now look at this question? 3 times 10 raised to power 6 times 5 times 10 raised to power 3. What is? number for number, indices for indices. Ohun tó jẹun la fi ń wéra wọn. That is to say, 3 times 5, what do you have? 15 times indices for indices. 10 raised to power 6 plus 3. So what do we have here? 15 times 10 raised to power what? 9. Gentlemen, don't never leave it this way. Never you what? Leave it what? This way. This is 15. You have to convert this 15 to what? In standard form. So this 15 become what? 1.5 times 10 raised to power what? 1 times 10 raised to power what? 9. So this one give me what? 1.5 times 10 raised to power 1 plus 9. 1.5 times 10 raised to power 10. Are we clear with that now? Know how to convert this. Thank you. 6 times 10 raised to power 4 times 5 times 10 raised to power 3. Look at this, number for number, indices for indices. 6 times 5, what do you have? 30 times 10 raised to power 4, join it together, plus 3. This becomes 30 times 10 raised to power 7. Now, you cannot leave this one this way. If you work it this way, gentlemen, you are halfway. So this one become, convert this one standard form, this one become what? 3.0 times 10 raised to power 1 times 10 raised to power 7. So this one become what? 3.0 times 10 raised to power 1 plus 7. 3.0 times 10 raised to power 8. You need to be mindful of this question. Move to law 2. Now we move to law 2. We say s raised to power a divided by s raised to power b equals to s raised to power a minus b. Whenever you see division, what do you do? You minus. Let's see question. If you have 1, a raised to power 7 divided by a raised to power 3. This become a raised to power 7, division become minus 3. A raised to power 4. Now let's see another one. 10 raised to power 5 divided by 10 raised to power 2. This become what? 10 raised to power 5. Division become minus 2. That become 10 raised to power 3. Now the same question here. Let's see. C raised to power 4 divided by C. Remember, I've said it. The other time that when you see anything, a representation with nothing on it, you should know that it is what? 1. So this become what? C raised to power 4 minus 1. So this one becomes C raised to power 3. Now let's see another one. What if you have, what have you come this way? You are D raised to power 6 divided by D raised to power 3. This is the same thing as what? D raised to power 6. Division becomes minus 3. What do you have? D raised to power what? 3. Now E. Let's see another one. What if you have 4x raised to power 6 divided by 4x? Don't waste your time. Number for number, indices for indices. Remember, 4x, this one nothing, you put 1. 4 cancel 4, number for number. So this one becomes cx raised to power what? 6 minus 1. What do you have? S raised to power 5. Now, from here, because if I take it, what if this question comes this way? See another one. 51 m raised to power 9 divided by 3m. Why are you wasting your time? This one, you can say number 3 here, 1. 3 in 51, 3. 3 here, what do you have? You have 1, remain 21, that is 17. So this one become m raised to power 9. Division means minus what? 1. So what do you have? 17m raised to power what? 8. That one is settled. Now, let's see. If you now have something like this, 8 times 10 raised to power 9 divided by 4 times 10 raised to power 6. Note, number for number, indices for indices. 4 here 1, 4 here 2. I keep it here. 10 raised to power, this become what? Times 10 raised to power 9 minus 6. 2 times 10 raised to power 3. Settled. Another question here that I say we need to see, understand is what? 3.6 times 10 raised to power 7 in bracket divided by 1.2 times 10 raised to power 3. Please be mindful of this question. So this one becomes what? Number for number, letter for letter, indices for indices. Now this one become what? 3.6 divided by 1.2. Clear? Times 10 raised to power 7 minus 3. 1.2, 1. 1.2 here. What do you have? 3. So what do you have here? 3. This becomes what? 3 times 10 raised to power 4. Settled. Yes. Yes. We want to go on 0 and negative power of indices. Gentlemen, anything raised to power 0 is what? 1. APC raised to power 0, 1. PDB raised to power 0, 1. Peter B raised to power 0, 1. Nigeria raised to power 0, 1. Africa raised to power 0, 1. Lord of Sim 2 raised to power 0 is 1. Let's quickly see this question. We have 10 raised to power minus 2. Minus become 1 over. When you see this minus, it become 1 over. Write what you have down. You have 10 raised to power 2. 1 over 10 times 10. 1 over 100. Now, let's see another one. 10 raised to power minus 4. Not quite long. Minus is same thing as 1 over 10 raised to power 4. 4 in 4 place. 1 over 10 times 10 times 10 times 10. Don't waste your time. Oh. How many 0? 1, 2, 3, 4. Over 1. 1, 2, 3, 4. Case close. Now, let's see question. We have what? X raised to power 5 times x raised to power minus 2. Now, watch here. Indices will become x raised to power 5 plus minus 2. So this one become x raised to power 5 plus as minus will give me what? Minus 2. X raised to power what? 3. The same over that one, the D. This question says that what? M raised to power 0 times n raised to power 0. Why are you wasting your time? M raised to power 0 is what? 1 times n raised to power 0, 1. 1 times man, you are in my own village is 1. Now, let's see another one. A raised to power, that is equation. You have a raised to power 7 divided by a raised to power, okay, a raised to power 2 divided by a raised to power what? 7. This one become what? A raised to power 2, division become what? Minus 7. What do you have? A raised to power what? Minus 5. You can see further take this one to be what? Minus is 1 over a raised to power 5. Are we clear with that now? Now we can also say, let's add this one. What if you have number f, you have p raised to power minus 2 divided by p raised to power minus 7. Watch out this. They become p raised to power minus 2, division become minus 7. Minus times minus will give me plus. So this one become p raised to power minus 2 plus 7. That become p raised to power what? Plus 5. Thank you. 1 over 2 raised to power minus 3. Now, this one I taught to a fraction. You can see when you have a fraction, this minus, instead of it to become 1 over, you say reciprocate. You what? Reciprocate. This one reciprocate means what we have down will go up, will come down. This one become what? 2 over 1 raised to power 3. That is the same thing as what? 2 over 1 times 2 over 1 times 2 over 1. That is 8 over 1. Now, let's see another question here. We have 1 over 3 raised to power minus 2. Minus, we have to make this one to what? To reciprocate. So this one become what? 3 over 1 raised to power 2. 3 over 1 times 3 over 1. What do you have? 9 over 1. The same thing as 9. Now, what if you have 1 over 9 raised to power minus 2? Raised to power minus 2. What do? This minus will reciprocate this. What do you have? 9 over 1 raised to power 2. It is the same thing as what? 9 over 1 times 9 over 1. What do you have? 80. A 1 over 1, that is 81. Okay. Now you can see similar question. You have 2a raised to power minus 1 times 3a raised to power 2. Number for numbers, letter for letter, sign for sign, and indices for indices. 2 times 3, what do you have? You have 6. A, conjugate this. You have a raised to power minus 1 times become what? Plus. You have 2. So this one become what? 6A minus 1 plus 2. I'm owing 1 naira. I pay 2. So what do you have? They must give you change plus 1. So you can take that one down. So and the last one here is what? 2A raised to power minus 1 times 3A into bracket 2. Of course, you need to open this. Everything inside this bracket is raised to power of 2. You must open this first. Now let's have it. 2A raised to power minus 1 times 3 raised to power 2. A raised to power 2. Now, let's transfer this one up. What do you have here? You have 2A raised to power minus 1 times 3 squared is the same thing as 3 times 3. What do you have? 9A squared. Join the number for number. 2 times 9, what do you have? 18. A raised to power minus 1 plus 2. You now have what? 18A minus 1 plus 2. What do you have? 1. 18 as 18A. Thank you very much. I am Corporal Bibola Abdulakim, blasting from Headquarters of Mecca Tutorial. We still want to consider other laws of indices outside like this. If you're in JSU, we want you to see advanced and see you have x raised to power a bracket b equals to x raised to power a times b. That's my next question here. If I have 3 raised to power 2 bracket 5, this one become what? 3 raised to power 2 times 5. What do you have? 3 raised to power 10. Now, what if you have we have x raised to power minus 8 bracket 2. This one become what? X raised to power what? Minus 8 times 2. What do you have? X raised to power minus 16. Now, what if you have something like okay, look at this question. Minus 4 into bracket y raised to power 3 square. Remember everything here. 1, you said this one become minus 4 times what? Y raised to power 3 times 2. Minus this one become what? Minus 4 y raised to power 6. What if you have minus 2 into bracket x squared y cubed all raised to power 2? Everything inside the bracket will only have the consign of this square. This one become what? Minus 2 dot x raised to power 2 times 2 y raised to power 3 times 2. They become what? Minus 2 dot x raised to power 4 y raised to power 6. I am done with this. The question can also come, what if you have it this way? Please, you have what? X raised to power 3 y raised to power 2 2 into bracket this. I put minus raised to power 2. Gentlemen, everything inside this bracket now will raise to power 2. Even the minus, the negative sign. Gentlemen, let's open it. Minus raised to power 2. Number 1. X raised to power 3 times 2. Because of law of indices, that's how you have to do it. Y raised to power 2 times 2. This one become what? Minus times minus. X raised to power 3 times 2, what do you have? 6. Y raised to power 2 times 2, what do you have? 4. Minus times minus will give me plus. X raised to power 6, y raised to power 4. Let's see another law here. Further law. If you have something like this, let's assume you have 4 raised to power 1 over 2. This side is not the same thing as 4 and a half or 4 number 1 over 2. 4 a raised to power. What you do, this one become 2 root 4. I carry this 2, I put it down. But 2 root 4 raised to power 1. What can multiply itself 2 times to get 4? It is 2. 2 raised to power 1. 8 raised to power 1 over 3. What will I do? 3 root 8 raised to power 1. What can multiply by itself 3 times to have 8? 1 times 1 times 1, 1. 2 times 2 times 2, what do you have? 8. So the answer is 2 raised to power 1. Let's see if you have 16 raised to power 1 over 2. What we say, this one become 2 root 16 raised to power 1. What can multiply itself 2 times to have 16? That is 4. 4 raised to power 1. What if you have it this way? To be 27 raised to power 2 over 3. Gentlemen, instead the same thing. They become what? 3 root 27. 3 root 27 raised to power 2. What can multiply itself 3 times to have 27? We have 3 raised to power 2. What do you have? 9. Of course, as long as you take for that question, what if you have it, you have 27. What about if you have 27 over 64 raised to power what? Minus 2 over 3. Don't bust. Watch again. The minus will make you to reciprocate this. That's the first thing you need to do. Never you work with minus. Negative things in life is not good. Remove this one. This one become what? 64 over 27. C raised to power 2 over 3. Mathematician, you should know why I remove here. I remove the minus. What happened? This one, I reciprocate it. Now, this one become what? 3 root 64 over 27 raised to power what? 2. What can multiply itself 3 times to have 64? If you try 2, no way. You try 3, no way. Try 4. You get your answer. 4 times 4, 16. 16 times 4, 64. So this place is 4. What about this? You should know it is what? 3. Or C raised to power 2. So this is the same thing as what? 4 times 4 over 3 times 3. That is 4 over 3 times what? 4 over 3. So what do you have here? 16 over 9. Are we clear with that now? So one whole number 7 over 9. Thank you. Yes. Good day, everyone. My student out there. You are welcome to make a tutorial platform JSU and Corporal Abdulakim. Of course, we are on indices this time around. You see, let me just give you a small scenario. One man day, the man they call him mathematics. The man come born three pikin, 3 children. The first one, see Mr. Math, he gave birth to 3. The first one is indices. The one is number base. And this third one is whole number. When they share the property, after the death of Math, they begin to find X, find Y. They find this and they kill X. Now, this first one, the senior one, carry his load. He carry and put for up. He carry his load, put for up. When they share the property, they drag and they go. Bagam. The second one, he hold am for body. Second born, he hold in load, he put am for body. Whole number, 8 times 2 times 3. The younger one, the load with the share, load 2 person. He carry a own, he dey drag am for ground. That is number base. So this thing has been shared. We are going to take it one after the other. Any mathematical expression in exponential form or that carry, you see, 2 raised to power 2, 10 raised to power 2, 5 raised to power 2, s raised to power 5, a raised to power 10. All these ones are what? Indices. And to solve indices, they say that about loss ìlú afọ́jú kan, you have to behave like that. That is to say, when you go to zoo, you have to behave like animal if you must live with them correctly. So what I'm trying to say here is that talking about indices, we have laws governing the solving of indices, be it in equation or expression. S raised to power A times S raised to power B equals to S raised to power A plus B. I go on with this. Example, law 1. See, S raised to power 5 times S raised to power 2. Sn representing S raised to power 5. When you see multiplication in turn to plus 2, they become S raised to power 5 plus 2. That is S raised to power 7. Y raised to power 5 times Y raised to power 3. These become what? Y raised to power 5 plus 3. They become Y raised to power 8. M raised to power 2 times M raised to power 6. These become what? M raised to power 2 plus 6. What do you have? M raised to power 8. if you have 2x raised to power 4 times 3x raised to power 2, remember, number for numbers, letter for letter, sign for sign, indices for indices. 2 times 3, you have 6. Represent this here because it's raised to power. This one is exponential, exponential. Represent the one. 4 plus 2. This gives me 6x raised to power 6. I still go on again. Now we can see how I take this one. 1, 2, 3, 4, and 5. Let's see if you have 8x raised to power 4 times 2x raised to power 2 times 3x. Of course, this number for number. 8 times 2, okay, 8 times 3, 24, 24 times 2, 48. This one becomes 48, number for number. Then indices for indices. There is nothing here, then you make it to be what? 1, the same thing as 1. So this one becomes s raised to power 4. Are we clear with that now? S raised to power 4 times become plus 2 plus 1. What do you have? 48s raised to power 7. Take it down and let us proceed. Minus plus 6. Open out this one by putting up plus. Plus times plus, plus 6. Plus, minus times plus, what do you have? Minus 6. Of course, you're supposed to give me 0. If you cannot arrive at this one, if you cannot do this one, use number line. 0, 1, 2, 3, 4, 5, 6, plus, 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 minus 1, minus 2, plus 6. I go on plus 6. Minus means I shift to the other side. So what to do here? Let's have it. 1, 2, 3, 4, 5, and 6. It ends here. So my answer, it ends here and you start here. Don't forget your arrow. So what do you have? The answer equals to what? 0. Now, let's see. Minus 6 plus 4. This one we put plus here. Plus minus will give me minus 6. Plus 4 will give me plus 4. Minus 6 plus 4 will give me what? Minus 2. Number 1. Let's see. And what if we have minus 6 plus 7. Put plus here to the right, so you open this bracket. Plus times minus, minus 6. Plus times 4 plus 7. Minus 6 plus 7. I am owing 6, I pay 7. What did they give you? Plus 1. You have to direct it to really show you know what you are doing. What if you have minus 6 plus 9? Now, what you need to do here, put plus at the back here. Plus minus will give me minus 6. Plus times plus 9. I'm owing 6, I paid 9. We'll give you change of plus 3. Let's see another one again. What if I have a minus 8 minus plus 10? What do you have? Put plus outside. Plus times minus, minus 8. Minus times what do you have? Minus 10. What do you have? You are owing 8. You are still owing another 10. What do you have? Minus 18. Let's see other direct. What if you have minus 3 plus 5 minus plus 8? What to do here? Now this one you put plus here. Plus minus you have minus 3. Plus times plus 5. Minus plus what do you have? Minus 8. First start from here. Minus 3 plus 5, what do you have? Plus 2 minus 8. Plus 2 minus 8, what do you have? Minus 6. And on a very, very last one on this note, you can also see have another one. If you have, let's see, minus 3 minus plus 7 plus 14. This one, I put plus here. Plus minus will give me what? Minus 3. Minus plus will give me minus 7. Plus times 1 will give me plus 14. Minus 3 minus 7. Minus 3 minus 7 will give me what? Minus 10 plus 14. See, I joined this side first before making here. So minus 10, I am owing 10. Plus 14, I have 14. If I pay, I need to pay my bill now. What do you have? Plus 4. On the directed number, please, you can say consult and do. If you have any problem, you can ask me. See director 08039 096141. on our WhatsApp or direct to Mecca tutorial. Thank you very much. Now, multiplication and division by power of 10. When you are multiplying a decimal by power of 10. Now, let's see. Number one here, your CSA, or to expect this one, 2.67 times 100. This one, you will look at it, the decimal is there already. How many zeros do you have here? You have 2. 2.67. You shift the decimal, so far it is plus. If it is multiplication, you shift to the right. What there? 2 times. Right, let's go. 1, 2. So my answer is what? 267.00. Or alternatively, you can leave it, no crime. Now let's say 3.41 times 1000. This is still the same. You can still write it. If you can write it this way, this is still the same thing as 10 raised to power 3. 3.41. It's still the same thing in standard form. Question can come this way. Please, don't shaking. So I'll say write 3.41. This is 3, and so far as multiplication, I shift towards the right. Just like corrected number towards the right. How many times? 3 times. Well, let's go. 1, 2, 3. The point is here now. This vacuum here, you put 0. You have 3, 4, 1, 0. Now, let's see another one. If you have 4.19 times 10 raised to power 4. You can see this one, you not put it down. Common sense. You don't have to waste your time. 4.19. 4 times, because multiplication, you shift 4 times. Right, let's go. 1, 2, 3, 4. You put 0 and 0 here. So my answer becomes 41900. Now, what if you have something like this? You have what? 8.17 times 10 raised to power 5. What to do? You don't waste your time. You just write 8.17. Right, let's go. 1, 2, 3, 4, and 5. 0, 0, 0. I have 817,000. Banker. I am done with this one. 0.05 times this one. I'll say this one is still the same thing as you writing now. 0.05 times 10 raised to power 3. That means this thing will shift 3 times. Alright, 0.05. Well, let's go. Because multiplication is to shift to the what? Right. Let's go. 1, 2, and 3. That is the decimal, you put 0 here. So what's my answer here? My answer is 50. All these ones are deleted off, so become 50. Now, what if it is division? Division. If a division, you shift to the left. Watch here. You have 25 or 2.5 divided by 100. What you need to do, this same thing as 2.5 divided by what? 10 raised to power 2. So for it is division, you shift to the left. I'll write 2.5. Right, let's go. 1, 2. 0. I'll put 0 in between. What do you have? 0.025. Now, let's see another one. What if I have something like this? I have 25 without any point. If I don't have any point, it's the same thing. It's just as if the point is here. 25 divided by 1000. I'll assume the point is here. I'll now write 25 divided by 10 raised to power 3. That means the to shift from here 3 times. So let's go. 1, 2, 3. I put 0. This one, you have what? 0.025. Also, 400.7 divided by 100 is the same thing as we writing 400.7 divided by 100. And the same thing as 400.7 divided by 10 raised to power 2. The point is here, division, I'll shift toward the side. What do you have? 400.7. Oh yeah, backward 2 times. Let's go. 1, 2. The point is here now. The decimal is here. What do you have? 4.007. No. It's 0.2. Now, this is decimal to convert to percentage. What to do? This become what? Is 0.2 divided by 100. Percentage. First and foremost, you convert it to fraction first. You convert it to fraction first. This one become what? Is 0.2 Points become 1, 0. That is 2 over 5. Sorry, 2 over 10. And the 2 over 10 now, you can now say times what? 100 over 1. 0 cancel 0. What do you have? 20%. If you have 0.25, you have to convert it. This one become what? Is 0.25. Point become 1. This one becomes 0, 0. What do you have? 25 over 100 times 100 over 1. Of course, 0 cancel this to the what do you have? 25%. B question C. If you have 0.45, convert from this amount to what percentage. First and foremost, convert to fraction first. Convert to fraction is 0.45 rule. The point become 1, 0, 0. 45 over 100. Percentage times 100 over 1. If you are to leave it in terms of what fraction, you can just call directly and leave. Now, here, 2 0 cancel 2 0 here. 45 times how do you have? 45%. Are we clear with that now? So, if you have something like this, now let's see, okay, what have you alpha is 0.95. This one become what? Is 0.95. Point become 1, 0, 0. So what do you have? 95 over 100 times 100 over 1. 2 0 cancel 2 0. What do you have? 95%. Thank you. Yes, I am Marvin Bola Abdulakim, blasting from the headquarters of Mekal Tutorial. Today we want to be seeing on that standard form. How do we go on standard form? Of course, number representation, if you have ordinary form representation of number. If I have 230, the first example 230, the representation 230 is in ordinary form, but this can be converted to what? A standard form. First thing we need to know is that is there a significant number here? Is there a decimal? Good. If there is no decimal here, we'll assume there is what? A decimal. I will say 230. I will assume the decimal here. We now take it 1, 2. How many digits did it get before you get to this number? That is 2. So this becomes 2.3 times 10 raised to power 2. Let's see another one. 4710. I will take this. I will assume there is no decimal here. You assume the decimal. Then last 4710. Put points here. Let's go. 1, 2, 3. This becomes 4.71 times 10 raised to power 3. Number 3, you have 48173 in standard form. There is no decimal here. I will assume, let's say 48173. I'll put my decimal here. Here, let's go. 1, 2, 3, 4. This one become what? 4.8173 times 10 raised to power 1, 2, 3, 4 raised to power 4. But by parameter, we now have a decimal. Number 4 with decimal. Let's we have 27.1 in decimal. They've really helped you. I'll take the decimal from here. I'll take it here. So this one becomes 27.1. This one, where let's go 1. Our answer becomes 2.7 times 10 raised to power 1. Another one, if you have 491.3 in standard form. This is ordinary form. Let's go back to standard form. You see, I'll write 491.3. I'll shift the decimal to the last number here. Let's see how many will it cross. 1, 2. So this one becomes 4.913 times 10 raised to power 2. Please quickly take this one down. Yeah, so that we proceed. Now, another one, let's see those one with assumption with decimal. Look at it now. Of course, the decimal will have to shift to the last. Definitely, this cannot shift, cannot over move again. So this one become what? 2.31 times 10 raised to power 0. It cannot move again. Remember the law of the indices. Anything raised to power 0 is equals to 1. So look at this one too. 4.213 times 10 raised to power. It cannot move again. Raised to power 0. What about it? 483.1 How many times can it go? Let's go 1, 2. This one become what? 4.831 times 10 raised to power 2. We see have another one. This one is still in standard form, become 7317.3. How many times will it shift? Let's see. 1, 2, 3. This becomes 7.3173 times 10 raised to power 3. Can you take this one down? And let us look at the standard form of those numbers that are what? Less than 1. Those numbers that are less than 1, I see those ones that start with 0 point. Now, the next one we move to, still on revision of algebraic, is expansion. How can we expand? Now, when you are expanding, that is, if you have a number, let's assume you have 2x, outside it you have 2. This one in bracket is in bondage. You have to open it. The number outside it is the key to open this bracket. To open this bracket, I'll say 2 multiplied by 2x. What do you have? 4x. Okay, what do I have? 2 into bracket 3x plus 4. This one because 2 times 3, what do you have? 6x plus 2 times 3, what do you have? 8. Now, what if I have minus 2 into bracket 3x minus 4? This one is directed. This number is directed. This one is not direct. Close plus. Plus minus will give me what? Minus. 2 times 3x, what do you have? 6x. 6 will give minus times minus plus. 2 times 4, 8. Are you clear with that now? Okay, now, let us see. Minus 3 to bracket m plus n. This one will give me what? You can see which one is not directed here. M is not directed, so I put M here. I put plus here. Plus minus will give me what? Minus. 3 times n, 3n. Minus times plus, everybody? Minus. We have minus 3 times n, 3n. Are we clear with that now? Yes. Okay, now let's see. Another one here. We have a minus 9 into bracket p minus q. Our reference book is New General Mathematics. Now let's see. This one is directed. Is this one directed? No. What will I put here? No. Plus. Everybody plus minus. You give me what? Minus. 9 times p, 9p. Minus times minus plus. 9 times q, 9q. Take it down. Alright. Let's see another one again. 2a plus 2a minus 4. I will take one of these to open this. 2a into bracket a minus 4. What remain here? Plus 2 into bracket a minus 4. Now, yeah, direct this one, direct it. Plus times 4, give me plus. 2a times a, what do you have? 2a squared. Are you clear with that now? Yes, then 2a times 4, what do you have? Minus. Plus minus, you give me what? Minus. 2 times 4, what do you have? 8a. Direct this one too. Plus plus, you give me what? Plus. 2 times a, 2a. Plus minus, you give me what? Minus. 2 times 4, 8. Now, you can see this a is raised to power 2. Yes or no? Yes, sir. This one raised to power what? 1. Power 1, 0. So, arrange the one that raised to power 2 separately. 2a raised to power 2. Minus 8a plus 2a. What do you have? Plus 6a minus 8. Clear? Yes, sir. Now, let's see another one again. What if you have a 3m plus 3 into bracket 3 into bracket 4m minus 3? Now, what is now? I'll take this one. First, this one become what? 3m into bracket 4m minus 3 plus 3 into bracket 4m minus 3. Let's close together. This one becomes 3 times 4, 12m squared minus 9m plus 12m minus 9. So this one become what? 12m squared minus 9 plus 12. What do you have? Plus 3m minus 9. Take it down. What? Minus 6a. Where? Minus 8a plus 2a. Sorry, minus 6a. Minus 6a. Minus 6a. Thank you. Minus 6a. Okay, interchange. On this one, interchange. Don't waste my time. This one become what? 2x into bracket x minus 2 plus 1 into bracket x minus 2. 2x times what do you have? 2x squared minus 4x plus x minus 2. That becomes 2x squared minus 3x minus 2. That is the answer. Are you clear with that now? Okay, take it down. Connect yourself. Now, let's see it again. Now, let's move to another step. Interchange your notes and say this question. Let us expand this. I've told you any number outside it is what you are going to use. This number is not directed. This one too is not directed. Minus plus times plus will give me what? Plus 5 times a 5 plus times plus 5 times 2 10. This one is not directed. Put plus times plus 4 times a 4 plus times plus 4 times 1 4. So you can see those one with a number for numbers,
Letter for letter,
sign for sign. Now you can do this one 5a 4a. Join them together. 5a plus 4a. This one is ordinary number. This one is ordinary number. Join them together. What do you have? 9a plus 14. Are you clear with that now? Are we clear with that now? Okay. Now let's see another one again. What if you have a 4 into bracket 3x minus 3 plus 4 into bracket 2x minus 2. Watch this now. To open this now, I'll need to direct the number. Make this one to be plus and plus. Plus plus will give me plus. 4 times 3, what do you have? 12s. Plus minus will give me what? Minus. 4 times 3, you have 12. Direct this one to plus minus will give me what? Minus. 4 times 2, 8x. Are you clear with that now? Minus times minus plus 4 times 2, you have 8. You can conjugate minus 8 plus 12. This one becomes 12x minus 8x minus 12 plus 8. 12 minus 8. 12 minus 8x. What do you have? 4x. Minus what? Minus 4. Are we clear with that now? Take it down, take it down, take it down, take it down. Alright. Let me just say this expansion. Let's keep this 5a minus 2b. 2a minus 3b. So I can give you a chance. Now, to open this, I'll take one of these to open this. Oh yeah, this one. Everybody, let's go together. N into bracket n minus 3n plus 5n into bracket n minus 3n. M times m squared. M times 3n minus 3mn. Minus what? 3mn. Right, let's go. This one, 5 times what do you have? 5mn. Plus minus will give me what? Minus 5 times 3, 15n squared. Are you clear with that now?
Yes, sir.
Are you clear with that now?
Yes, sir.
Everybody, S times S. S times S.
S squared.
S plus S. 2S. S plus S.
2s.
M times M. M squared. M times M.
M squared.
M plus M.
2s.
So, this one now, if you leave it this way, you don't have issue. And if you rewrite it, m squared minus 15n squared minus 3m. This one and this one, they are mn. Yes or no?
Yes,
so
sir.
you can remove them. So this one becomes what? Plus 2mn. Are we clear with that now?
Yes.
Are we clear with that now?
Yes, sir.
Take it down. Now let's see. Okay. We have 5a. The second question. Concentrate and what? The second question will become what? 5a into bracket 2a minus 3b minus 2b into bracket 2a minus 3b. 5 times 2, what do you have? 10a squared minus 15ab minus 4ab plus 6b squared. So this one becomes what? 10a squared minus 19ab plus 6b squared. Yeah, take it down. And let's now 2n plus 4 bracket 3n minus 2. Take this one first. Everybody, let's go. 2n into bracket 3n minus 2 plus 4 into bracket 3n minus 2. Now let's go. 3 times 2, what do you have? 6mn. Are you clear with that now?
Yes, sir.
Minus 2 times what do you have? 4n. 4 times 3, what do you have? 12n minus 8. n. Is there anything you can join here?
No.
You leave it that way. Are you clear with that now? You can see 4x minus 6 into bracket 2x minus 2. If I want to do this one become what? Okay, let me make this one to be y. This one become what? Let's go. 4x into bracket 2y minus 6 into bracket 2y minus. What times what do you have? 8xy minus 8x minus 12y plus 12. Watch here. Watch. This one become what? 8xy minus 8x minus 12y plus 12. That becomes our answer. Are we clear with that down?
Yes, sir.
Take it down. Kasi calm down. As your revision on the algebra, as you remain Corporal Bimbola Black in blessing from headquarters of Mecca tutorial. Now, substitution. What we mean by substitution, another name for substitution is replacement. Another name for substitution is replacement. When you are playing football, one gets injury, they will replace it with another person. Now we can do it here mathematically. Let's see. My reference group is New General Mathematics. Now let's say I say find the value of the following. Find the value of the following when x equals to 4 and y equals to minus 5 and my z equals to minus 3. Question 1, you should find 2x. Now to find 2x here, you can see this one is setting as 2 is already know times x. What's my x? 4. 2 times 4, what do you have? 8. Now let's see another one. Question 2, you have 6b. 6b, we have 6y. 6y will become what? 6 multiplied by minus 5. This number is directed, yes or no?
Yes,
we have to direct this one by pushing it with plus. Either plus minus will give me what? Minus 5 times 6 what? Minus 30. Let's see another one. 3 minus 8x. Minus 8x. Minus 8, this one become what? Minus 8 into bracket x, which is what? 4. Once one of the number is directed, direct the second one. This one become what? Plus. Plus minus will give me what? Minus. 8 times 4.
32.
We have 32. Are we clear with that now?
Yes, sir.
Now let's see another one. YZ. YZ. The meaning of YZ is y times z. So what is my y? Minus 5. What's my z? 3. This one is directed. You have to direct this one. Yes or no? What will I put here?
Plus.
I put plus. Plus times minus will give me what?
Minus.
5 times 3, you have 15. Are we clear?
Yes, sir.
Take it down. Now, so this is the question. You have x, y, z. We have to substitute this value. Anywhere I see x, you replace it here. My x equals to what? 4 multiplied by xz. My y is what? Minus 5. Multiplied by my z, that is what? Minus 3. Remember, this one is directed, this one is directed, this one directed.
No.
What would I add here?
Plus.
I'll add plus. Everybody, let's go. Plus times minus.
Minus.
Minus times minus.
Plus.
You have plus. 4 times 5.
20.
20 times 3, you have 60. Now, the second question. X plus y. The value of my x is what? 4. This one becomes 4 plus minus 5. Are you clear with that now?
Yes,
so this one plus minus will give me what?
Minus.
So this one becomes 4 minus 5. What do you have? Minus 1. Now, next one, x minus y. What's my x? 4. Minus y. Minus 5. Everybody, minus times minus will give me what? 4 plus 5. What do you have? 9. Now, the next one is z minus s. My z is what? Minus 3 minus 4. Everybody, minus 3 minus 4. Minus 3 minus 4.
Minus 7.
I am owing 3. I am also still owing 4. So, how much am I owing altogether? Minus 7. Now, the next one, let's see. X plus y. X plus y. This question, x plus y. My x is 4 plus minus 5 over z over minus 3. Plus minus will give me what? Minus 4 minus 5 over 3. What do you have? Minus 1 over minus 6. Minus cancel minus. What do you have? 1 over 3. Take it out. Of the following. Well, number 1, we have 3x. Of all the factors of this, it's going to be number 1. If you have 3x, 1, of course, 3, and you have you have x. These are the factors of this. B, or let's see another one. You have a, b. What are the factors? Things that can go here. You have a and b become the factors. Then what about you have c? 10m squared. 10m squared. Let's find the factor of the number. That is 1, 10. You have 2. 2 can go here. You have here 5. Then m becomes what? M and what? M. These are the factors of 10m squared. What about 25pq? If you have d, 25pq. Of course, what find the factor of 25? Of course, 1 in 25, you have 25. What can go again? 5, you have 5. Then the other factor for p, you have p, and you also have what? Q. They become the factor of it. Now, we now move to what? Highest common factor in terms of what? Algebra. In terms of algebra. Yes. Find the HCF of, we have 2xy and 7xz. First and foremost, what you need to do, first find, we start with 2xy. And factors there, you have 1, 2, and you have x, and what? You have y. For 7, you have 7xz. 7xz becomes what? 1, 7, and we have what? X, and we have z. What are those things that are common here? What are those things that are common here? Of course, we have 1 here, of course. 1. What do you have again? That you have up and down, we have what? X. X. So if you add these ones together, my x here become what? X. Now 10m squared and 15m squared to find the HCF here. First take this one become 10m squared, it give me what? 1. 1 can go here, 1 in 10, it give me what? 10. 2 can go, or it give me what? 5. Any other factor, 3 cannot go without remainder, 4 cannot go, 5, you already have it here. Then we have m squared. M squared is the same thing as m times m. Now, what about 15? 15m squared. The factor, the first one, 1 in 15, you have 15. 2 cannot go 3, what do you have? 5. 4 cannot go 5, you already have it here. And you have m squared, that is m and m. M and m. Let's see, is there anything that you have up or down? You have 5. 5. What do you have again? You have m, and you also have m. So what do you have here? 5m squared. Now, the first one to find the HCF of this, what you need to do, first take 18x squared y. This one, okay, let's take it this way. I'll first take 18. Let's see. We have 1 can go, 2 can go. 1 here you have 18, 2 here you have 9, 3, and we have 6, and we have what? X, and what? X, and what? You have y. For 27, 27x squared y. What are those things that can go here? 1 in 27, 27, 2 cannot go, 3, you have 3, we have what? 9. Those are the factors you have here. And the next one here is you have what? X, and you have what? XX, sorry, XX, and you also have what? Y. So, what are those things that appear up and down? Of course, we have, look at it here, we have 3, it appears up and down. What appears again? We have 9. We also have what? 9 that appears here. Of course, what do we have again? We have what? X. We also have, what do you have again? You have what? X here. And you also have what? Y also appear. X, X, and you also have what? Y. Now, highest, my highest one factor here is going to be what? What do you have here? Up here you have 9. 9 appear the highest. And what about here? What do you have here? Can tell me, what do you have here? You have x. X also see appear here. You have what? 9x. Clear. CF. To find the ACF, another method that you can adopt here is to say 16. You have 16, you can rule. You have x, you have y square. Another method, 2 here. What do you have? 8. You have sy squared. 2 here, we have 2 sy squared. 2 here, you have what? 2. Sorry, 2 here, you have 4. Sorry. So 2 in this, what do you have? 2 sy squared. 2 here, what do you have? 1 sy squared. Then x, when x go here, what do you have? 1. You have what? 1. You have y squared. Then you have y. Here you have 1, you have y, and you also have what? Y here, you have what? 1. Now, I'll go with the second one again. This one becomes, let's have it 4 euro s, the question is s square y. You see s square y or s square y square? The question is s square 4xy. Very good, 4xy. 4xy, I see rule, this one become y. 2. 2 here, what do you have? 2xy. 2 here, 1xy. X here, what do you have? 1, you have y. Y here, 1, 1, 1. So, from here, let us analyze all this and bring it out. This is another method of finding LCM. Now, ICL. 16xy square will give me, let's go. 2 in 4 plus is 2 times 2 times 2 times 2 times x times y times y. And for that of 4xy will become what? 2 times 2 times x times y. What are those things common here? 2 here, I take it down. 2. 2 is also here, I take it down. What do you have? 2. What is common up again? You have what? You have x times x and times y. Times y. So what do you have here? 4xy. This is another method you can also see adopt. Thank you. Now, LCM, lowest common multiple. We want to see find the LCM of this expression. So find the LCM of this expression. Please follow me up. We have here, if we have 3x squared y and 2xy squared, I can adopt this one to become what? Watch it. Take it together. 3x squared y. 3x squared y. What do you have here? 2x y squared. What can go here? Let's see 3. Let's start with the number first. Yeah, 3. You have 1 x squared y. 2xy squared. 2, we see add 2 here, 2. Let's go. 1 x squared y. 1 xy squared. X. This one go. When x go in this one, become what? X, y, 1, y squared. Let's say go x again. X again. So this one, x here again, what you have? 1. X here, you still have 1, you have y, 1, you still have y squared. Now, we have y here, still go with y. Y here, what do you have? 1, you have 1, and you remain y here. I cannot divide it with y again so that you have 1. So my LCM is going to be what? 3 times 2 times x times y times y. So 3 times 2 you have what? 6. X times x squared y squared. That becomes the what? LCM. And 5b squared. Now let's have it. Now the LCM of this, I can easily rule it. 6ab, I rule. Then the other side we have what? 5b squared. 5b squared. So let's see the factors that can go. 2 here you have 3, a, b, 5, b. Sorry, 5b. This one still remains b square. What again there? Let's say 3. 1. A, B, 5, and B square. You see, proceed. 5. 1. A, B, 1, B square. Let's go with A. A here, what do you have? 1. 1, B, 1, B square. Let's go with B. When B go here, 1, 1. Did B cancel this B? What do you have? 1. Here, you see, have 1. This one remain B. Then we have B here. You have 1, 1, 1, 1, and 1. So my LCM become what? Becomes 2 times 3 times 5 times A times B times B. So what do you have? 2 times 3 is 6. 6 times 5, what do you have? 30. A, B squared. That becomes the LCM. X, Y squared and 4xy. I'll take this. Now this one become what? 16x y squared. We also see right side 4x and y. Now let's go here. 2 here, what do you have? 8xy squared. 2 here, you have 2xy. Okay, let's go again. 2 here, what do you have? 4xy squared. 2 here, you have 1xy. What do you have here? 2 here, you have 2xy squared. 1. 1 here, you have xy. Let's say again. 2 here, what do you have? 1. You have xy squared. Xy. Now, can I go with x? X here. When x goes here, what do you have? 1. You see, you have y squared, 1, and you have y. Then y can go here. 1, 1, you have y. 1, 1, and you also have 1. Then you can use the last y to cut this one out. So my LCM is going to be what? 2 times 2 times 2 times 2 times x times y times y. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 x y squared. Following. Now let's see. Number 1. 12c plus 6d. You have to know what is common here. 6 can go here. 6 can go here. This can become what? 6. When 6 go here, what do you have? You have 2c. When you multiply 6 times 2, 6 will give you this. Plus, what do you have here? D. 6 times d. I am done with this one and factorize this. Now, let's see db. Part we have to factorize. Let's see another one. 4a minus 8b. What is common here? 4 can go. You write 4 in brackets. What do you have? A minus, what do you have? 2b. We make the size. Now, we also have another one. Let's see. What if you have xyz minus ayz? Now, what you need to do? What do you have here and you have here that common? You have yz here. So if I were you, I'll write yz into bracket. What remain? When yz cut out here, what remain? X. I put it here minus yz. When yz cut out here, what do you have? A. I have factorized this one. And also, let's see another one. If you have 3d squared e plus 5d squared. What is both common here? D is common. Like d squared is common. And what again? Nothing. Take this one. D squared into bracket. What do you have? When d squared go here, what do you have? 3e. 3e plus when d squared cut out there, what remain? 5. I have factorized all this one. Thank you very much. Now, we want to go to our addition. Let's now go to our addition and subtraction of algebraic fraction. Addition and subtraction of algebraic fraction. Addition and subtraction of algebraic fraction. When I talk of fraction, you should know something over something. Addition of algebraic fraction. Now let's see. What if you have 7a, number 1, 7a over 5 minus 4a over 5. They both have a common denominator. Don't waste your time. Write one of it and rule it. They become what? 7a minus 4a. What do you have here? 3a over 5. Number 2. What if you have 9b over 2 minus 3b over 2? They have a common denominator. So you write 2 and you rule it. They become what? 9b minus 3b. Don't waste your time. This will give me what? 6b over 2. 2 here, 1, 2 here, 3. We have 3b. Number 3. What if you have x over 2 plus x over 3? Gone, bang, gone. It don't happen. Yet they are not the same thing. You need to what? Find the LCM of this one. The LCM of this is what? 6. I rule it. 2. How many 2 can you see here? 3. 3 into bracket x. This is 3. How many 3 can you see here? 2 plus 2 into bracket x. So this one give me 3 times x. What do you have? 3x plus 2x over 6. What do you have? 5x over 6. Okay. Another question. Okay. A over 4 minus A over 20. You need to find the LCM. The LCM of this one is going to give me 20 because 4 can go there. 4. How many 4 can go here? You have what? 5. 5 into bracket A minus 20. How many 20 you see here? 1. 1 into bracket A. So let's open out the 5 times. See what do you have? 5A minus A over 20. What do you have? 4A over. So 4A over 20. So 4 here, 1, 4 here. What do you have? A over 5. So let's just see another one. If you have 6x over 5 minus 3x over 4, the LCM of this one is going to be 20. I roll it. 5 here, what do you have? 4. 4 into bracket 6x minus 4 here, what do you have? 5. 5 into bracket 3x. 6 times 4 do you have? 24x minus 15x over 20. 24 minus 15, what do you have here? 9x over 20. I am done with that one. Now we can see what does it take 1 again. What if you come this way? And remember, my reference notes is New General Mathematics, book 2. What if I have 3 over x plus 1? Nothing. Gentlemen, fraction, this one will make it over 1. The LCM here is going to be x. You rule it. X here, what do you have? 1. 1 into bracket 3 plus 1 here, what do you have? X. X into bracket 1. What do you have? 3 plus x over x. That becomes what? My answer. Are we clear now? 2a minus 3 over 2 plus a plus 4 over 2. Now, what you need to do here, they have a common denominator. The LCM is 2. I wrote 2 here. Let's see. 2 here, what do you have? 1. 1 into bracket what? 2a minus 3 plus 2. 2 here we have 1 into bracket a plus 4. So what do you have here? This one, a times what do you have? 2a minus 3 plus a plus 4 over 2. 2a plus a, what do you have? 3a minus 3 plus 4. What do you have? Plus 1 over 2. I am done with this one. Number 2. Let's see again. What if you have 3b plus 4 over 3 plus 2b minus 5 over 3? They have a common denominator. You represent it with 1, 3, and I rule. What the way this one is going? 3 here, 1. This one become what? 1 into bracket 3b plus 4 plus, what do you have? 2b minus 5. 1 into bracket 2b minus 5. So if I open this one, what do you have here? 1 times this, you are going to have 3b plus 4 plus 2b minus 5 over 3. 3b plus, what do you have? 5b. We have what? 4 minus 1 over 3. I am done with the answer. You submit. Now, the LCM of 6 and 4 is going to give me what? 24. I rule it here. 4 here, what do you have? 6. 6 into bracket 5x minus 3 plus 4 here. 6 here, what do you have? 4. 4 into bracket x minus 3. So what do you have here? 5 times 6, what do you have? 30x minus what? 6 times 3, 18. Plus what? 4x minus 12 over what? 24. 30 plus D, what do you have? 34, sorry, 30x plus 4x, what do you have? 34x minus 18 minus this, what do you have? Minus 30 over what? 24. Of course, if I like, I can try to just factorize it. That what is common, what can go in all? 2 can go. If you know 2 can go, this can be what? 2 into bracket. What do you have here? 17x minus what? 15 over what? 12 over 12 into bracket. So this and can cancel out this. Clear? So you can further see add it to the what? 17x minus 15 over 12. Thank you. Now, if you have m minus 1 over 6 minus m plus 1 over 8. Now, you need to find the LCM of it. If you know, don't go and multiply. If you know, you don't know how to go about it. First, find the LCM. 6, you have 8 and a row. What do you have here? 2 here, 3, 4. Again, what do you have here? 4, you have 3, you have 3 here. So my LCM is 2 times 4, 8, 8 times 3, 24. My LCM is 24, I rule here. 6. How many 6 can I see in 24? How many 6? 4. So you have 4 into bracket m minus 1. Minus, you have to be very careful. How many 8 can you see here? 3. So it becomes 3 into bracket m plus 1. Let's open this one. This one becomes 4m minus 4. You this one to have open this minus 3m minus 3 over 24. Now, are you clear with that now? 4m minus m will give me what? M minus 3 minus 4. What do you have? Minus 7 over 24. Thank you. We have to simplify 3x plus 1 over 4 minus x minus 5 over 4. If you have any doubt, Thomas, you can tell me general mathematics. Now, this one, the LCM is what? 4. I write 4, I rule it. 4 here, 1, you have 1 into bracket 3x plus 1. 4 here, what do you have? 1 minus 1 into bracket x minus 5. Open out the bracket. 1 times what do you have? 3x plus 1 minus s plus 5 over what? 4. 3x minus s, what do you have? 2x. 1 plus 5, what do you have? Plus 6 over 4. Gentlemen, you can also factorize this one. What is common here? You have 2 into bracket x plus 3 over what? 2 into bracket 2. 2 cancel 2. S plus 3 over 2. Okay, my use 6b plus 5 over 7 minus 4b minus 6 over 21. Now, if I check, if you don't know, find the LCM. The LCM of these two is going to give me what? 21. So I write 21, I rule here. 7. 7 here, what do you have? 3. 3 into bracket 6b plus 5 minus 21 here, what do you have? 1 into bracket 4b minus 6. Now, 3 times c, what do you have? 18b plus 15 minus 4b plus what? Plus 6. Plus 6 over what? 21. 18b minus 4b. 18 minus 4, what do you have? 14b. 15 plus 6 plus 21 over what? 21. What is common here? Don't leave it this way. Always to the lowest. 7 can go here, 7 can go here, 7 can go here. Here becomes 7 into bracket what? 2b plus 3 over what? 7 into bracket what? 3. 7 cancels 7. So my final answer is what? 2b plus 3 over 3. Thank you. Yes, good day, viewers. I am Corporal Abimbola Abdulakim, blessing from Headquarters of Mecca Tutorial. Of course, we are seeing a basic operation of a fraction. Of course, we said a fraction says something over something, or it's a number over number, or letter over letter. We have to call on basic operation of on a fraction. This time around, we have to call on multiplications, the multiplicative aspect of it. Multiplication. Now, what does? You can take this to be over 1. This is a fraction. This is whole number. That's why we say 8 over 1. If there is nothing called true, you can say 8 times 2, what do you have? 16 over 3. You cannot leave this like this because this one is what? Improper fraction. 3 can still go here. 3 here, what do you have? 5 whole number, 1 over 3. Remember, my reference book is New General Mathematics, JS1. Of course, we're on page 27 now. Let's see another one here. We have 12 multiplied by 3 over 4. This is a fraction. Of course, this is whole number. I make this one to be what? Over 1. This become what? 4 here. There's not, if you check the sense that can cut, make sure you cut to reduce the work volume of what the division. So 4 here 1, 4 here 3. This can be what? 3 times 3. What do you have? 9. 9. I move to what? Number 3, which is 5 times 3 over 10. This one, you see, this is a fraction, make this one to be what? Over 1. Now, check. Is there anything that can cut? Yes, of course, 5 can go here. 5 here, 1, 5 here, 2. What do you have? 3 over 2. You have to check what kind of fraction is this one. This one is improper fraction. You can convert it to what? Mixed fraction. How many 2 can go here? This one become what? 1 whole number, 1 over 2. We move to another example here. Let's see example 4. From here we have 2 multiplied by 2 over 5. This is a fraction. Make this one to be in fraction. Mathematics is flexible. Very easy if you follow the radar rules. Now, let's see, is there anything that can cut? No. 2 times 2, what do you have? 4 over 5. What kind of fraction is this? This is proper fraction. It can only lead you to what? Decimal. Can you take this one down and let us proceed? Yes. This one on significant figure, we are done with GP, decimal places, and that one you start counting after the word, the decimal point. But this one, we continue with significant word figure. With the significant figure. Now, once SF to one significant figure, to one what? Significant figure. The first important number you have here, what's the first number you have here? 2. But after the 2, what do you have? 9. 9 equal to what? 1. So if you add 1 to this one, what do you have? 3. So this one become what? 3, 0, 0, 0, and 0 for this. 1 SF. Are you clear with that now? If they say to 2 significant figure, to 2 SF, I'll write the first 2 number 29. But after 9, what did I say? 9. 9 for the category of what? 1. So I add 1 to this one. So this one become what? 0, 3. Remember, all this one will turn to 0, 0. So this one becomes 0, 0, 0. Are we clear with that now?
Yes.
Now, they say this one to 3 significant, to 3 C, to 3 SF. 3 significant figure, to 3 significant, they become what? What will I write? What are the 3 important numbers? 2, 9, 9. After the 9, what do you have here? 8. 8 for the category of what? 1. If you add 1 to this one, what will this one give me? 0, 0, 3. Remember, 1, 2, 3. See how other 2 digits? Add 0, 0. This one becomes to 3 SL. Take it down and let us proceed. Axis goats and Z cow. Goat, cow, sheep, everything, they are all what? Animals. How many? The question is how many animals does he have? Now the farmer, the solution here, number of goats equals to 6. Number of cows equals to Z. Total number, goat and cow are animals. So total numbers of our animal equals to what? The goat, that is 6, plus the cow, Z animals. Take it down. For example, Abimbola is 35 years old. How old will he be in 5 years' time? My present age of Abimbola is what? 35 years. Then in 5 years time is going to be what? 35 plus the 5 years time 5. Total, what do you have? 40 years. It's going to be 40 years in 5 years' time. Now, the big question is why years' time? In Y years' time, Abimbola is going to be the present age. Present age is what? 35. In Y years' time is going to be what? 35 plus Y. Yes, you can see. Now, and this C question, 5 years ago. 5 years ago, that means it has passed. 5 years ago. 5 years ago is going to be the present age is what? The present age is 35 years. Then 5 years ago, 5 years ago is going to be what? 35 minus 5, which is going to give me what? 30 years. Now, of course, the question, why years ago? Why years ago will give me what? The present year, which is 35, minus y years. Please check out this example. You see the difference years ago and years time, the difference between